Hello and welcome to another episode of What the Heck is Steve Talking About? Today we're going to go over inductors and capacitors do in a circuit. We're going to go over how they react with the voltage that's in that circuit. It's going to be a short video, not really any math or anything like that. I'm just going to show you on the power meter that I have here behind me how inductance and capacitance react, and we'll try and give you a visual on the meter to what that looks like. So let's give it a shot. Okay, so let's start by going over our acronym of Eli the Iceman. You've probably gone over this in class with your instructor. But what this means is it's just a way for us to remember how current and voltage react with each other depending on if there's inductance in a circuit or capacitance. So we have Eli, we call this Eli the Iceman. Eli, E-L-I, stands for voltage, inductance, and current. And you can see the I, which represents the current, lags behind the voltage in an inductive circuit. The ice part of this means we're talking about capacitance in the middle here, and we have the current I leads the voltage in a capacitive circuit. So that's the way that we memorize how these two react in a circuit. Eli the Iceman. Current lags voltage in an inductive circuit, and current leads voltage in a capacitive circuit. So I've drawn a little graphic here, which I'm sure you've seen before. This is just a resistive circuit, and in a purely resistive circuit, current is in phase with voltage. That's how we refer to it. So if you look here, the red line refers to voltage. The blue line indicates the current. And if this is a purely resistive circuit, think of it as a horse race, right? Over time, if this is a horse race, they both come out of the gate at the same time. And you can see at 90 degrees, current and voltage are the same. And as we come over to 180 degrees, they're still the same. Current and voltage run side by side in a purely resistive circuit. Okay, and in a second here, I'm going to get you a closer shot, but I just wanted to show you what I have wired up and what I'll be showing you on this power meter. So I've got some resistive load here that I can control, and that will show us the current being in phase with the voltage, as I just showed you on that graph, and we're going to see that on the scope here in a minute. I've also got some capacitors over here that I can toggle switch in to the circuit to change, and then on this side I've got an inductive load to again throw the current out of phase with the voltage. So I'm going to zoom in a minute so you can get a better shot at the screen and see actually what's going on, but I just wanted you to get a wide view of the circuit that I've got wired up here on our trainer. Okay, so as you can see here on the meter, I believe you can see the scale here. That's just the voltage that it's reading right now. I don't have any kind of a load on this circuit, but I am going to introduce say 300 ohms of resistance. And when I do that, you can see the graph changes. Now here's the current being displayed, but you can see it's peaking at the same time the voltage is. It's what we would say it's in phase with the voltage. It reaches the 0 point at the same time. Clearly that's in phase. Okay, so now I'm going to add some inductance to this circuit. And our acronym Eli tells us that with inductance the current lags the voltage. So I'm going to put in, what, 0.8 henries, which is about 300 ohms. And let's see what happens. The current should now lag the voltage. And look at that. Like I explained before, here's the voltage coming out, and it's peaking right here. But about 90 degrees off, the current is peaking. And it matches the graph that I drew. I'm going to take away the inductance, and we're going to put in 8.8 microfarads of capacitance. And what do you know? The current leads the voltage. Now this line's a little choppy. That's the capacitor charging and discharging. But you can see that our Eli the Iceman acronym is correct, and that the current leads the voltage in a capacitive circuit. How about this? We'll put some resistance back in, and we know that's going to be in phase with the voltage. And I'll put a little bit of inductance in there, and you can see it shifted just a little bit, right? If I get rid of the resistance, you can see it shift a little more. So they really do offset each other, as I'm sure you've learned in class. So give me just a moment. I'm going to set this up on a different kind of indicator, and I'll show it to you that way too. Okay, so here we are with our different graphical to show you the same idea, essentially, is what it is. So right now, this is indicating just the voltage that we see there, and I'm going to introduce some resistance. And we know the resistance is going to be in phase with the voltage, so it's actually going to put a line exactly with this line here. So let's go ahead and do that. Sure enough, it's showing you there's a black line. It's hard to see, I know, because one line's over the other because they're on the same phase angle. So let's get rid of that resistance, and we'll show some inductive load. And you can see there, right here, that's about 90 degrees out of phase with our voltage. That's what the other scope showed us also. This is just showing it in a different fashion. Now I'm going to shut off the inductance and turn on some capacitance, and you're going to see it out of phase, but it's going to go the other way because we know that inductance, the current lags, and capacitance, the current leads. So here's our capacitance added to the circuit, and sure enough, it's off by 90 degrees, but the other way. And again, I can add and mix capacitance and inductance. There's both. So now it's off by less than 90 degrees. And in fact, they use capacitance and inductance methodically to make what we call tuning circuits. So we get a circuit where we want to tune out the phase shift between the current and the voltage, and we know how to calculate the proper amount of capacitance and inductance to do that. And then with different amounts of capacitance, like you see here, the phase angle is going to change. I'll put in a different amount of inductance, and the phase angle is going to change yet again. So to be clear, if I were putting just resistance in here, you would see the phase angle would be the same as the voltage. If I were to put just capacitance, you would see it off by 90 degrees. And if I were to put just inductance, you'd see it off by 90 degrees. Okay, so I hope you enjoyed this episode of What the Heck is Steve Talking About? And I hope you learned a little something about capacitive and inductive circuits and how those items react in a circuit. And if you have any questions, my email will be below. You can certainly get a hold of me that way. And if I can't answer your question, I'll get you in touch with somebody who can. So thanks for watching.